Hey, Miss Smart here with today's assignment, which was page 65, numbers 1 through 7. So, a fan blade spins counterclockwise once per second. So, one full rotation each second on this fan. So, going counterclockwise, the blades of the fan are 1 foot long and the height is measured in feet from the center of the fan. So I'm going to go ahead and just draw an x-axis and a y-axis. And the height is measured in feet from the center, so in feet from here. And we're going counterclockwise. So this right here at P where it starts at a time of 0 would be a height of 0. And then it comes or it goes in this direction. So up here would be a height of 1. And when it gets over to here, the height would be 0 again. And then down in this region, when it gets down to here, the height's going to be -1. It's 1 foot below the center of the fan. And then back up to a height of 0. So what happens is that the fan's height starts at 0 and then goes to 1, to 0, to -1, and back to 0, all in 1 second because it's once per second. So since this is happening twice in 1 second, so it's not A. B and C are both starting at 0 and headed to -1, so that's going in the opposite direction. But you can see graph D down here starts at 0 at a time of 0, maxes out at a height of 1, then back to 0, a height of -1, and then back to 0, all in 1 second. So it is answer D, or graph D, I should say. Okay, the next question we're looking at, this is a select all to apply. Which situations are modeled accurately by a periodic function? So remember, a periodic function will repeat the outputs in the same interval of time. So the distance from the Earth to the Sun as a function of time. So if this is the Sun and this is the Earth rotating around, it's periodic because it's like the same orbit, right? Year after year after year. So A, that would be periodic. B, the vertical height of a point on a rotating wheel as a function of time. So think of all the Ferris wheels we've done, where there's like the center of the Ferris wheel, and then, you know, it goes around and around and around, and it's repeating, assuming it's going the same speed the whole time. So yes. C, the area of a sheet of paper as a function of the number of times it's folded in half. Every time you fold a piece of paper in half, it gets smaller and smaller and smaller and smaller and smaller, which means that none of those outputs are going to repeat because it's constantly a smaller value the one before. So not C. The D, the number of centimeters in X inches. Well, the number of centimeters in inches, you know, that's not going to repeat. It's going to be a little linear formula, so not D. E, the height of a swing pendulum as a function of time. So it goes, let's see, where am I? Okay, there we go. So it goes this way and this way and back and forth and back and forth and back and forth. And you can see the height values where my, pen is, keeps repeating. So yes for E. And then finally, the height of a ball tossed in the air as a function of time. It looks like it's just being tossed once. It goes up, it comes down, it repeats once. Periodic means it repeats over and over and over and over and over and over and over. So not just one toss of a ball. So not F. Okay. The next one, here's a graph of some values of x. Can you extend the graph to the whole plane so that the function is periodic? Explain your reasoning. Yeah, we certainly can. I'm going to just kind of fill in some guidelines because I see this has a minimum value of 1, and a maximum value of 2. So these are just guidelines since it's not a gridded, it's not already gridded for me. So I can kind of see if I want to make this periodic, then I'm going to have that little section of the graph repeat over and over in the same space, or same amount of space. So it goes from 1 to 2 in an interval of 1. So I'm going to make it go back down in another interval of 1. I made it a little bit too short. It should have like reached all the way over here to the 2. So let's pretend it did. And then kind of keep it going that way, like a little zigzag. Same idea back here. Let's see if I can line this up a little bit better. Maybe there. May have overstretched that one as well, but you get the idea. Just trying to make, you know, assuming that these were all like exactly the same going back and forth, that would make it periodic. Something that would make it not periodic is just if we were to say, oh, let's make it into a line. So there's a periodic and then not periodic. Well, anything that the outputs don't repeat over and over is not periodic, so just a line. Number 4, can a non-constant linear function be periodic? Explain your reasoning. A non-constant linear function. So a constant linear function would be a line that is horizontal. A non-constant would be any sort of line that has a slope, either a positive slope or a negative slope. So it's asking, can these be periodic? And again, the answer is no, because you're not going to have output values repeat over and over. So no for A. Then the next question, what about a quadratic? Well, a quadratic graphs a parabola that either opens up or it opens down. Neither of those would be considered periodic, even though their values repeat. Like they're going to have the same output on each side, but it's not over and over and over. It doesn't turn around and go back and turn around and go back and turn around and go back like a periodic function does. So this is also no. Okay, number 5. Do 7, 1 and negative 5, 5 lie on the same circle centered at 0, 0? Okay, so let's see here. If they lie on the same circle centered at 0, 0, then I should be able to come up with, you know, where this is 7 and this is 1, and this is, let's say, r for the radius of the circle for the first one, and then for the second one, this is negative 5, this is 5, and this should be the same radius r. So if I can get those values to be the same, then I can say yes. If they're not the same, then I would say no. So for the first one, r squared equals 7 squared plus 1 squared. That's 49 plus 1, which is 50. So if r squared is 50, then r is equal to the square root of 50. On the second one, here, r squared equals negative 5 squared plus 5 squared. That's 25 plus 25, which is 50 again. And so the radius is equal to the square root of 50. So the answer here is yes. I can show that the radius for each of these when centered at 0, 0, so this would be 0, 0, and this would be 0, 0. We get the same radius, so they must be on the same circle. Number 6, for an angle that measures between 0 and 2 pi radians, which statements must be true? of the sine of theta and the cosine of theta. Select all that apply. So A must be true. That's actually the Pythagorean identity. B, if the sine of theta is 0, then the cosine of theta is 1. So I'm going to go ahead and just draw a unit circle. Okay, there are two places where the sine of theta is 0. Right here at 1, 0. So this part's true, the cosine of theta is 1. But then over here, this is negative 1, 0. So this is not always true because here where the sine is 0, the cosine is negative 1. So B is not an answer choice because it's not always true. It says it must be true, not all the time, because it could also be negative 1. Okay. Now the other way around, if the sine of theta is 0, if the sine of theta is 1, then the cosine of theta is 0. So there's only one place on the circle where the sine is equal to 1. It's up here at pi over 2. Cosine is 0, sine is 1. Down here, cosine is 0, sine is negative 1. But it's saying if the sine of theta is 1, so that's right here, then the cosine of theta is 0. Yes, that happens right here and only there. Okay, D, the cosine of theta plus the sine of theta is equal to 1. That's not true. This is the true cosine squared plus sine squared. This happens sometimes. 1 plus 0 is 1 in those two places, but here we have 0 and negative 1, so it wouldn't add up to 1. And then finally, E, the point cosine theta sine theta lies on the unit circle. Yes, that's what we've been working on for over a week now. So yes, for sure, for point E. All right, and number 7, the center of a clock is the center of a clock is the origin 0, 0 in a coordinate system. The hour hand is 4 units long. What are the coordinates at the end of the hour hand at 3 o'clock, 8 o'clock, and 11 o'clock? All right, so one more time, here's a little circle. And I'm going to go ahead and highlight the X and Y axis. This makes it easier to figure out what we're talking about. Okay, what are the coordinates at 3 o'clock, knowing that this is 4 units long? Okay, so at 3 o'clock, this is at 0. Over here is pi, pi over 2, pi over, 3 pi over 2. Okay, and so right here, the coordinates would be 1, 0, right? Right here, 1, 0. However, if this is 4 units long, then it's going to be 4 times 1, which is 4, and 4 times 0, which is 0. All right, at 8 o'clock, so 8 o'clock right here. We worked on this same kind of idea yesterday where we figured out that the angle right here was 7 pi over 6. And so 7 pi over 6 has a cosine of negative root 3 over 2 and a sine of negative 1/2. So the exact coordinate would be 4 times the cosine of 7 pi over 6, 4 times the sine of 7 pi over 6. Okay, so those are exact coordinates. And then I can use my calculator to get an approximation. And so 4 cosine of 7 pi divided by 6 is about negative 3.46. And then the sine of 7 pi over 6 is 1/2, so I don't really even have to put that into the calculator. So this one was about negative 3.46. And then the sine of 7 pi over 6 is negative 1/2. So times 4 is negative 2. And then last but not least is at 11 o'clock. 11 o'clock is right here. And 11 o'clock is at the angle 2 pi over 3. And see how it has like those really similar values as the 7 pi over 6 that we just did. And so the exact, knowing that this is 2 pi over 3, then the exact coordinates are going to be 4 times the cosine of 2 pi over 3, comma, and then 4 times the sine of 2 pi over 3. Okay, so again, the cosine of 2 pi over 3 is negative 1/2. So times 4 gives us negative 2. And then 4 times the cosine of 2 pi over 3. Well, it's going to be positive because it's up here for y. And it's that longer leg, that root 3 over 2 leg. So we already evaluated it up here. So instead of negative 3.46, when it's up here for sine, it's positive 3.46. All right, that is the end of your assignment.